here are the batteries and the isolation transformer and inverter charger all in the kind of enclosure that I've made. As you can see, there's not really enough room for it all. So I kind of suspected this. So also these two, the two blue Victron boxes, they need to be raised up off the floor. They've got fans on the bottom, so they need enough ventilation. So I kind of suspected that I might have to find somewhere else for them. So I'm going to do that today. The prime candidate for the place to put these the Victron boxes is here. So this is the quarter berth, because I think there's probably going to be enough height here. I'm probably going to put them here and there. This is plywood, so I can definitely attach them there. Might put another backing plate on just to give them something really secure to hold on to. So I'm going to look at doing that now. One thing that's good is that it makes wiring it in slightly easier, because the lazarette actually comes round from the side here, so I don't need to drill any holes to get the mains cable from where it comes into the boat round to here. Right, I better get all this stuff out. Hello there, it's Tuesday and you join me on a very jancy day in Scarborough Harbour. It's been made a bit worse by the fact they've taken the bar out in the harbour entrance, so we're getting a lot more waves coming in from the bay now. I think I might get seasick if I try and do too much work down in the cabin. So yesterday I had a successful evening. I managed to mount the isolation transformer, which was pretty difficult to do actually, because I was working in a very small area. It's the old quarter berth and it's very, very heavy. So what I had to do was prop it up with lots of sheets of plywood and then kind of slide it down onto the mount. Anyway, I got it there in the end, and my task for this evening is to wire that up to the RCD, which is connected to the mains input. So let's see how I get on with that. Here's the isolation transformer mounted on a nice good thick bit of backing, so that should hold it up. So if you go through, you can see just at the end there's a little bit of a light. So round that corner is the lazarette. So if I can get the cable fed through, I should be able to connect it to the RCD, because the RCD is actually in the lazarette. Here's the lazarette, and here is where the power comes in. I've already attached the first RCD here. It is going to go on the wall just there. I've got a backing pad and I've just got some thickened epoxy. I kind of chickened out and bought some ready-made up thickened epoxy that you can dispense from like one of those gun type things. I thought I can't learn too many things at once, but at some point I will sort out learning how to mix fiberglass and that. So here is a piece of string that goes around into the quarter berth. So what I need to do is attach the cable to that piece of string, pull it through, making sure that I leave enough string in the quarter berth so that I can pull the string back again. Right, so I've got the cable here going up there. It's attached by a knot that I hope will work. And what I need to do, I think, is secure the other end to something so that I don't accidentally pull it through. I'll do that now. That was a lot easier than I thought. Turns out I was a lot closer to the lazarette than I thought I was. I thought there was a big hole that I had to go over between the pilot berth and the lazarette. And it turns out when I looked through, the cable was just about there. So the next job is to wire this in to the RCD. Okay, so that's wired in. And now time to do the other end. So here's the input, live in neutral earth. Now what I'm going to do temporarily, there's a little thing that says if vessel onshore, connect J34A with PE wire to J34, so that's from there to there. So I'm going to connect that, and then when I put the next bit in, I need to wire it differently. So I've got the live neutral earth, live neutral earth. So that's the input, that's the output. And temporarily I have wired in just this 4-way, and as I say, I'm going to connect these earth points together. The reason is that, well, it's those earth points. The reason for that is there's an earth point on the bottom of the boat, which is a kind of sea earth. I don't have that connected up at the moment, so this is not the full solution, but I do just want to check that it's all wired up properly and it's working properly. So I've got the new cable plugged in, and the first thing I need to do is check whether the RCD is working. So if I turn it on now, it clicks on. If I press the test button, it goes off. So that looks like that's working. So first thing on, and next thing to do is see if this one works. So this is the 16 amp, which is the one I've got plugged in, and that appears to be on. So let's have a look inside. So it's all wired up, and you can see there's a green light over there, which I'm going to kind of assume is good. I've got the earth strap, which I've checked is linking the earth on the input to the output. So, and then if we look down here, that is now glowing. So I've got 240 volts. So I'm just going to turn everything off again while I put the front plate back on, but I think that's pretty successful for the moment. I've just used the RCD tester to turn the power off. This light is no longer on, and in here there's no green light, so I think I am safe to put the cover back on. So the isolating transformer's been running for a few days now, and without any problems apparently. It does make a bit of a hum, which surprised me. I suppose it shouldn't have done. And yesterday I managed to put the inverter charger on its backing pad against the wall here. So what I'm going to do today is get all this wired up, if I have enough cable and the right connectors. First thing to do is to build the battery. Now I'm just going to put it all together at the moment because I don't know where it's all going to go. I need the motor controller so that I can see where everything needs to be, and that still hasn't arrived, which is a little bit annoying. So I'm just going to put it all together now and see whether I can wire it up. And this at the very least will enable me to measure up for any cables which I need to get, because the ones I've got are too short. So what I'm hoping to achieve today is that at the very least I'll have another shopping list of stuff that I need to get, and this maybe will be the last one, so that I can fully wire everything. So they are all laid out. Looks quite neat, doesn't it? So first thing I need to do is check that I've got them all in the right polarity, all the right way round. Hi there. So slow progress yesterday. I've managed to figure out one place where the batteries could go. Of course, until I get the controller for the motor, I won't really be able to finalize the configuration, but I think I've got something that works. The annoying thing is, so no matter how you set the batteries out, you've got to have a voltage sensor on each cell in the battery, and the wires are not long enough. So I've been extending the wires, which of course makes it a really slow job. Maybe I could have done that before, but because I didn't know what configuration it was, I couldn't do it before I brought all the batteries down here. So there's kind of a lot of clambering about at the moment to make sure that it all fits in. Another thing that I found that was a little bit annoying yesterday was I wanted a short piece of the high power battery cable just to join the two banks, because effectively I've got two banks of 24 volts. And the only way that I've got of cutting these thick battery cables at the moment is using a hacksaw. And the problem with that is that I have found if you're trying to cut a very short piece of cable, you end up just pulling strands of the cable out. So I've done a bit of research and I found what a proper cutter. Ordered that off eBay. That's supposed to be arriving on Tuesday. So in the meantime, I'm going to carry on wiring up the battery sense cables, you know, and then I can test it, all that kind of stuff. And also I will wire in yet another RCD as the output of the inverter charger, so that hopefully anything that happens beyond the inverter charger will be protected. That's my task for today. This is where I got to yesterday. I've got to the far end of the battery, so I need to just come back. I think there's 1, 2, 3, 4 that I'll need to do, and then the wires are long enough. The one that's missing is here. So between this bank, the front bank, and the back bank, I need a connector there. Unfortunately, the shape of the batteries means that you can't quite fit one of these on. It's slightly too long. So I'm just going to have a short piece of power wire. What I might do is find a piece of cable, because obviously I'm not going to run 300 amps through it today. I think the maximum that the inverter charger draws is 50 amps, which should be fine, you know, with some of the existing battery cable that I've got lying around. So I might just do that, and you know, as a temporary thing so that I can test it. I've got all of the cables connected up. I was watching a YouTube video on wiring, and they said if you want to make things look like a professional, then you need to make it really neat. So what I will be doing here is using some zip ties just to neaten up all of these things. But because I don't precisely know where everything's going to go yet, I'm not going to do that. So this will look really, really neat once it's done. But for the moment, it's just going to look like that. Now, the next thing to do before you plug into the BMS, and this is a really important piece, is you need to check that all of the wires are in the right order. So the way that you do that is you put a multimeter on and just check that you've got a rising voltage, so you know 0, 3.2, 6.4, 9.6 and so on, right up to the top. Because if any of these are the wrong way round, and I have actually connected them the wrong way round, and you plug it into the BMS, it will blow the BMS and you'll have to buy a new one. So that's a really important step to do, which I will be doing next. In my last episode, I was trying to cut a short piece of this 50mm squared battery cable in order to just link the two 24 volt sections. And as you can see, all that I had that I could do it with was a hacksaw, and it was pulling out the individual wires of the cable. So I did a bit of research online and I found this. Now, this is a Ratchet cable cutter. You can buy battery powered versions of this, which seems ridiculous, but this is a hand cranked one, and it should do the job. I'm going to give it a go now. we go. So that's compared to previously, that's a very nice neat end. I'm just going to cut another one the same size now, and that'll make the connector. So that is the new little connector between the two banks. I checked everything up, we've got 56 volts, so well over the nominal 48 volts. All very good. Hi there, I had quite a good day yesterday. That was Friday night. I actually finally connected up the battery to the inverter charger, and that all seems to work okay. There's a long weekend, Saturday, Sunday, Monday, so hopefully I can make really good progress. Today, what I've got on the list is I'm going to wire up a battery cutoff switch. I'm going to wire up the 240 volts output, and I'm going to wire up the output of the isolation transformer into the input of the inverter charger. So hopefully where I'll be able to get to today is that I'll have that whole circuit working, so that I can have the shore power coming in and powering stuff 240 volts, and then when I turn the shore power off, the inverter will kick in and I'll still get the 240 volts, but this time off the batteries. Let's see how I do. So here's the positive and negative going to the inverter charger. I know it's all a bit of a mess at the moment, but what I'm doing is I'm just running all the wires, making sure that I've got everything in place, and then once I've figured out where everything's going to go, then I'll kind of tidy it all up and I'll run it through holes and conduit and so on. So first thing today is to look at wiring in the switch. So I've got positive connector there. I know that that's an 8mm, so unfortunately that's going to have to come off because the switch is 10mm, and then I need a wire that's going to come from that switch to the fuse box. I've decided to wire it to that side of the fuse box because this is a distribution thing, so I want to turn everything off at once. And the other thing is, because the BMS has got a cutoff, 300 amp cutoff that works really, really well, I think that that's pretty safe. Basically, I've got the switch unfused. I might put an inline fuse in at some point, but I do really think that that's overkill. So one of the things about inverters is that they've got very big capacitors connected to the inputs. And when a capacitor is discharged, it effectively acts as a short circuit to ground. So you've got, you know, the 48 volts just going straight to ground, which is obviously not a good idea. So I've been doing a bit of research around this, and what they suggest is using a resistor to limit the current while the capacitors charge up. What I'm going to do is make this a permanent thing, but what I've got at the moment is I've got this little resistor here. This is a 50 ohm, what is it? No, it's not. It's a 10 ohm 50 watt resistor. So when it's switched off, the power flows through the resistor and it charges up the capacitors. And then when you switch the switch on, then that means that you can get the full power through, and that seems to work pretty well. So I am going to make this into a permanent thing. This is just kind of a setup to get it going, and wire in probably a 1 kilo ohm resistor there on a push switch. I've seen other people do that, and that would solve that problem. So if ever I have to turn the battery off using that the big power switch, what I can do is before I turn it on, I can charge up the capacitors with a little push button and a resistor, and that will mean that I don't get any sparking, and I don't damage the input capacitors, because that's the other thing. If you get a very large inrush current, you know, it's shorting the life of the capacitors. So that's a piece that I haven't seen done many other places, so hopefully you'll find that useful. So we've got the inverter running now off the battery, and then through this RCD all turned on, and then around here I've got it into some waterproof sockets, and I am making my first cup of tea using battery power. I'm boiling a kettle, and you can see it's pulling 16 amps from the battery, so actually not too much. I think it's one of these low current, you know, hotel style kettles. It does take an hour to boil, so obviously not a lot of power going out, but that's great. Cheers everyone. Bit hot.